In this video, we are going to continue our discussion of 11.3 dot products. We're going to relate this to work. Maybe you've seen this in physics. If not, the good thing is I'm going to give you the definition. So when we measure work, what work is it's the component of a force along a directed path. So what that means is like, take a look at this picture here. It would be like dragging something here maybe with the force upwards, and we're dragging it across this distance d. The amount of work would be let's define it. Work is a force times a distance. If you haven't seen this, you will see it in your Physics 1 courses when you get there. We are going to now relate this, and we want to over distance d. And if I look at my picture here, I got a right triangle. We are trying to work on the force going across here. That's what we're really worried about, is covering this whole distance along this path. So I need the horizontal component of F, or of this triangle here. So I'm going to call this question mark, call this theta. Well, that is a cosine. So cosine of theta is equal to question mark over that side. That's not F, it's magnitude of F, right? The side. So that means the question mark here is equal to magnitude of F times cosine theta. That is my horizontal component. So if I'm rewriting this definition of work, work is, okay, that force is going to be written like that. F times cosine of theta. And then we times this by the distance, which is the magnitude of that d vector. Okay, if I follow this out, rewrite it, work is capital F, that vector, times the magnitude of distance times cosine. Now, recall, we're going to use this definition a lot. Cosine of theta is u dot v over the magnitude of u times the magnitude of v. So if I multiply, where did w come from? If I multiply both sides by that denominator, u dot v is equal to let's put those up front, the magnitude of u times the magnitude of v times cosine theta. All right, take a look at what this is. If I have something like this, I can go to that. It's just the dot product of the two things that are inside. So that means that work is actually, okay, if I look here and I use that same, it is just my F vector dotted with my distance vector. That's it. That's all it is. Using that definition, this is what's going to be required of you. You're not going to derive this or anything, but we know work is force dotted with distance. And we probably could have made that assumption based off that. Now, that wouldn't be mathematically correct to say, hey, that just means that vectors, but we showed it. Okay, but now we can use it freely. That's what I'm going to expect of you. All right, first example says find work given that the force is that, and then a particle moving from one point to the other. We have F, we just need distance covered. I'm going to do component form, and that's just Q minus P. 2 minus negative 1 is a 3. 1 minus negative 2 is a 3. And 5 minus 2 is a 3. I'm going to write down F2 in component form. I got 2, comma, 3, comma, negative 1. These all should have hats on them, but I guess missed it. So work is F dotted with D. So that means we got 3 times 2 is 6, plus 3 times 3 is 9, minus 3. So it gets me 12. So the work done would be 12 foot-pounds. Whatever we're talking about. We actually don't know the units in this one. All right, last example for this. A wagon is pulled. Okay, so I'm going to draw a wagon. My wagon. By exerting a force of 65 pounds on a handle that makes a 20 degrees angle with the horizon, or with the horizontal. So I have something like this. The handle's up this way. And I know that it's 65 pounds being pulled that way. So I know this side is a length of 65. All right, so we have that. And then we have actually our angle here. That is 20 degrees. And then they said they're going to drag it for 50 feet. All right. Okay, so The definition I probably want to use for this one would not be f dot d, because I would have to define, I'd have to find what is the vector for f, and I'd have to find the vector for d. D is not that big of a deal, but f wouldn't be fun. So actually, instead of using the green definition, we should use this definition. So that is, work is the magnitude of f times the magnitude of d times cosine of theta. We have every bit of that. The magnitude of f is 65, the magnitude of d is 50, and then cosine of 20 degrees. This ends up being, if you plug all that in your calculator, we get 3,054 foot-pounds. Okay, so that's how you find work. We have two different definitions. It just depends what you have. If force and distance is described as a vector, or can be, you'd want to use the dot product. If not, we'd want to use this other definition.